Hey everyone, have you ever been driving over a huge bridge or watching a plane land and had that little thought in the back of your mind, how do we know this thing is safe? Well, today we're going to pull back the curtain on the incredible and mostly invisible science that keeps our world from falling apart: structural health monitoring. It's a question we just take for granted, right? We put our trust in these massive structures every single day. But that trust isn't just blind faith. Nope. It's built on a foundation of constant vigilance and some seriously clever engineering. See, the thing is, every structure, from the tallest skyscraper to the quiet road in your neighborhood, is always under stress. And over time, daily use, the weather, it all causes tiny hidden issues to pop up. And the real trick, the real challenge, isn't fixing a giant crack you can see. It's finding the damage before it ever gets that big. So how in the world do we find these hidden problems? Well, get this. Structures are actually talking to us all the time. You can think of it like they're going for a regular checkup. We just have to know how to speak their language. And that language, believe it or not, is the language of bending. Okay, I know that sounds a little poetic, maybe, but it is literally true. When a structure is put under a load, like a big truck rumbling over a bridge, it responds. It moves, it flexes, it bends, and every single one of those tiny movements is packed with information, telling a story about its health and its strength. And that movement has a name. It's called deflection. In engineering, this is a huge deal. It's kind of like when a doctor checks your pulse or blood pressure. Engineers measure deflection to get a read on a structure's health. It's one of the absolute best ways to see what's going on and catch problems before they become disasters. And you know what? The physics behind it is actually pretty straightforward. Let's walk through it. So first, you have a beam, just sitting there. Then, step 2, you add a load. Let's say a car drives onto it. Step 3, the beam bends or deflects just a tiny bit. And here's the magic part, step 4. By precisely measuring that tiny dip, engineers can figure out the health of the whole thing. A tiny change in how it bends today versus how it bent last year, that could be the very first sign that something's wrong. Okay, so we know structures are talking through bending. How do we listen in? Well, engineers have this whole toolkit of what I like to call high-tech stethoscopes to do exactly that. It kind of breaks down into 3 main approaches. First, you've got on-site sensors, which are physically attached to a structure to feel every little vibration. Then you have vision-based systems, basically super sharp cameras watching from a distance. And finally, you bring in the big guns, powerful computer models and AI that sift through all the data to predict what might happen next. Now, all of those are super cool, but I really want to zoom in on the vision-based systems for a minute, because honestly, these are a total game changer. And here's why they're so powerful. Instead of just checking on a bridge once in a while, a camera system can watch it 24/7, giving you live, real-time data. And get this, the system is so smart, it can tell the difference between the bridge bending from traffic and just, expanding a little bit because it's a hot day. That means the data you get is incredibly clean. So how does this magic work? It's so clever. First, you just point a high-res camera at the structure. Then, special software looks at the surface and basically memorizes the unique pattern of pixels, like a digital fingerprint. Then, when the structure bends, even a fraction of a millimeter, the software sees those pixels move. It measures that tiny shift and turns it into a super accurate deflection reading. And the best part? It's all done from a distance. No climbing, no wires, just watching. And look, this isn't some futuristic sci-fi stuff. This tech is out in the world right now, making things safer for all of us. Let's check out a couple of real-world examples. First up, long-span bridges. Just picture one of those huge, massive bridges stretching across a bay. They're always moving, and keeping an eye on their health is a gigantic job. Right, so you obviously can't stick a sensor on every square inch of a bridge that's miles long. It's just not practical. So engineers have to be smart. They take measurements from just a few key spots, and then, this is the cool part, they use computers to build out a full picture of how the entire bridge is bending. It's an incredibly effective way to see the big picture of its health. All right, let's jump from bridges to something else that takes a real beating, an airport runway. Can you even imagine the forces at play here? It's immense. Think about it. A massive plane slams down on the pavement over and over and over again. That's a huge, sudden shock every single time. And this is where those camera systems are just perfect. You can set them up a safe distance away, and they just watch, measuring that tiny pavement flex with every single landing.
This helps them spot potential damage early on.
Okay, and for our last example, let's bring it right back home, to the roads you and I drive on every single day. You might have even seen one of the special trucks they use for this. There's this really cool tool called a falling weight deflectometer. What a name, right? It literally drops a big weight onto the road and then measures the ripple that it creates in the pavement. And from that one little test, engineers can figure out the health of the road underneath and know exactly when and where they need to send the repair crews. So what's the big picture here? Why does all this matter so much? Well, because understanding deflection, it's completely changing the game for how we take care of our world.
This is the key thing to remember. For the longest time, we were always reacting. A road would crack, a part would fail, and then we go fix it. But now, by listening to this secret language of bending, we can be proactive. We can catch those tiny problems when they're still tiny, which is way safer and, let's be honest, way cheaper in the long run.
Okay, so let's recap the whole thing. What did we learn? 1. Deflection is basically a structure's pulse. It's #1 vital sign. 2. Awesome new tech, especially those camera systems, lets us watch this pulse in real time. 3. This all adds up to safer infrastructure for every single one of us. And 4. It's about being smart, preventing disasters instead of just cleaning them up.
And that just leaves me with one final question for you. This whole world of deflection analysis, it's just one piece of this incredible, invisible science that's always working around us. So it kind of makes you wonder, right? What other hidden systems are out there, quietly making sure our world keeps running smoothly? Something to think about. Thanks for joining me.